Key concept 8, target D.
Yeah, YouTube channel is at Matt Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
The main topic of target D is correlation and causation. So if you remember from target 8B, correlation is when there's a relationship between two sets of data. So if X is increasing and Y is increasing, we say that there's a positive correlation. An example of that would be the more hours you spend studying, the higher your grade. Negative correlation is when X increases but Y decreases. So an example of that would be the more times you're absent, that's going to increase. Your grade's going to decrease because you're missing more stuff. And then no correlation means that there's no relationship between the two variables. Now, the next word we're talking about is causation. That tells you that a change in one variable causes a change in another variable. So I'm not only saying that there's a relationship now, but I'm saying that when X changes, that's causing Y to change. And that's not always the case. Okay. So an example here, there is a strong positive correlation between ice cream sales and the amount of shark attacks. As the number of ice cream sales increases, so does the number of shark attacks. Is it reasonable to conclude that the number of ice cream sales is causing the amount of shark attacks to increase as well? So here's the x-axis, right? And we have the y-axis, okay? Both are increasing. So the number of shark attacks is increasing, the number of ice cream sold are increasing. So it's almost a straight line. So there's definitely positive correlation here. So there's a relationship. As one increases, so does the other one. However, would it be enough to say that the number of shark attacks is causing the number of ice cream sales to increase? Obviously not. That would be a little bit crazy to say. So there's something else that's causing both of those to increase, right? And that is what we refer to as a lurking variable, okay? Lurking just means there's a variable that's hiding in the background, something that's not mentioned in the graph, but that is making both of those increase. So in this case, it's the weather. So if you notice, in May, they're both pretty low, but as soon as June and July hits, where there's warmer weather, more people are going to go out and swim. So if there's more people out in the ocean, they're more likely to experience a shark attack. Same thing with ice cream sales. The hotter the weather, the more the ice cream sales are going to increase. So the lurking variable is the temperature, which is not part of the graph to begin with. That's why it's called a lurking variable. It's hidden in the background. So correlation means that there's a relationship. Causation means that changing one causes the other one to change. So in this scatter plot that I gave you guys right here, there is correlation. So there is a relationship because they're both increasing, but there is no causation because increasing one is not causing the other one. Example 1. Identify the relationship between the variables for each graph and fill in the blanks. A. English teachers at District 201 did a study on the number of books owned and the number of hours students spend reading a week. Okay, and then they want us to fill in the blanks on the bottom. So the bottom says, as the number of books owned, blank, the hours spent reading each week, blank. So we read a graph from left to right. Here's the x-axis, the number of books owned. Here's the y-axis, how many hours spent reading. So if we go always from left to right, first thing they want to know is what's happening to the x, the number of books owned. So from going from left to right, we start at 0 books, 1 book, 2 books, and we go all the way up to 10 books. So the number of books is increasing. So we can put increasing in the first blank. Okay, and they want to know as x gets bigger, what happens to y. So now we're looking at y, how many hours spent reading each week. It starts here at 1, and then it keeps going up all the way to 10 as well. So as the number of books owned increases, the hours spent reading each week also increases. Okay, keep in mind again, graphs must be read from left to right, because if we were to read this in the opposite direction, you might think that it's decreasing, but that's not necessarily the case. All right. Example 2. Read each scenario and identify the type of correlation, whether it's positive, negative, or if there's none, that exists. So A, A doctor has worked for the same hospital for 15 years. What relationship would you expect between the number of years she has been with the company and her annual salary? So first thing you want to identify is the two variables we're looking at. So we want to know what's going to happen between the number of years she's been with the company and her annual salary. So we're assuming, she just got the job, but with time, time's going to increase, right? So she'll work for the company for 1 year, then 2 years, and 3 years. So the number of years is going to increase. And we're assuming that the longer she stays with the company, the more money she's going to make, the more salary. So her salary is going to increase as well. Now, when both variables are increasing, that's what we call a positive correlation. All right, B. B says, I write down the shoe sizes of all my students. What relationship would you expect between their shoe size and their grade in my class? So again, before you identify the correlation or the relationship, you need to identify what two variables you're looking at. In this case, I'm looking at shoe size and their grade in my class. Okay, so I think it's safe to assume that the size of your shoe is not going to determine your grade in my class. We're not going to all of a sudden find out that people with small feet have better grades or the other way around. So in this case, because there's no relationship, we say that there is no correlation. Okay, which means that there's no relationship between the two variables. And then C says, I buy a dozen donuts in the morning and leave them in the lunchroom. What relationship would you expect between the number of minutes passed and the remaining amount of donuts? So again, identify your two variables, the number of minutes passed and the remaining amount of donuts. Okay, so the assumption here is that I leave donuts in the morning in the lunchroom. So what's going to happen to how many minutes has passed by? That's obviously going to increase, right? So 5 minutes will pass by, 10 minutes, and so on. So the number of minutes passed will increase, and then what's going to happen to the donuts? So I buy a dozen donuts, so I bought 12. As time happens, I'm assuming either I eat them or someone's going to come in the lunchroom and also eat them. So however many donuts is left is going to decrease. When X increases and Y decreases, that's what we call negative correlation. Okay, and that was it for part 2. Example 3. For the following situations, determine if there is a correlation. If there is a correlation, determine if it's likely a causal relationship. Okay, so example 3 is very similar to example 2. We still want to know what kind of correlation is there. Determine if there is correlation. The new step here, though, however, is determine if it is a causal relationship. All right, careful. That word is not spelled casual. Okay, it looks like it might be if you mispronounce it, but it's pronounced causal, which is basically they're asking you, do you think changing one is causing the other one to change as well? All right, so let's take a look at example A. We're looking at the number of hours you spend practicing free throws and your free throw percentage. Okay, so how many hours you practice and your free throw percentage. For those of you unfamiliar with the concept, free throw percentage is, let's say I attempt to shoot 10 free throws, right? And out of those 10, 7 go in, but 3 don't. So I made 7 out of the 10 shots, which means I have a 70% free throw percentage. Okay, it's how many actually go in be over how many you actually attempted. So we're assuming that you're going to spend more hours practicing, right? Because you're trying to get better. And then the assumption here too is if you practice more, your percentage is going to get better, right? Maybe you start by only making 2 out of the 10 shots, but if you keep practicing, maybe you move on to 3 and 4, so your percentage is going to increase. So we're going to say that the correlation is positive. Remember, that was just the first part. The second part is, do you think it is causal? So do you think me practicing is causing my free throw percentage to go up? Most likely it is. I can't say 100% for sure because there's always exceptions, Someone might say, I've been practicing forever and I'm not getting better. But I would say most times out of all the times, if you practice more, you're going to get better at something. So we'll say positive correlation and then we'll put and likely causal. Okay, likely causal means we're pretty sure that they cause each other. We just can't say that for sure 100% of the time that's going to happen. But the probability or the chance of it happening are pretty high. All right. Moving on to the next one. The number of days you exercise in a week. Okay, so that's my first variable. And how much you weigh. So again, we can make the assumption here that you're gonna exercise more days. So maybe you only exercise twice a week now, but with this extra time on your hands, now you're moving up to 4 or 5 times a week. And we're assuming that the more you exercise, the more weight you're going to lose, right? So how much you weigh is actually going to decrease because you're losing some weight. So if one increases and the other one decreases, that is what we call negative correlation. And then the second part was, is it likely causal? So do you think you exercising more days a week is causing you to weigh less? And again, you can't say 100% for sure every single time that that's going to happen, but most of the time, you can confidently say that the more you exercise, the less you're going to weigh. So we'll say, and likely causal. Okay. Of course, there's always exceptions. There's more involved with losing weight than just how much you exercise. Genetics, you could also think about diet. So the last one we're looking at is the number of socks you own, and how many friends you have. Okay, I think this one's a little bit obvious. I would imagine that there's no relationship between how many socks you own and how many friends you have, right? You're not gonna find out that the more socks you own, the more friends you have, right? And the other way around is true too. So in this case, there is no correlation, which means that there's no relationship. And if there's no relationship, you can't tell me if they cause each other because, well, there's no relationship to begin with. Example 4a. For the following situation, determine if there is a correlation. If there is a correlation, is it likely a causal relationship? So this is very similar to the one we just did. First, they wanted us to figure out if there's correlation. So is there a relationship? And then if there is a relationship, is it a causal relationship? So is changing one causing the other one to change as well? All right, so the situation we're looking at here is the amount of hours worked per week and how much money you make. So we're assuming the amount of hours you work is going to increase, right? Maybe you're only part-time, you're working 20 hours a week, you get promoted to full-time, now you're working 40 hours a week, so that increases. How much money you make. If I go from working 20 hours to 40 hours, obviously the amount of money I make is going to be more, right? That is, of course, if you're making an hourly wage, which means, maybe you're working at a supermarket and they're paying you 10 bucks an hour. When it comes with teachers get paid what's called a salary. So each year, let's say maybe we make $50,000, right? No matter how many hours we work, we're still going to get paid $50,000. But in most situations, if you consider jobs like working at the mall or supermarkets, they get paid hourly, which means the more hours you work, the more money you make. So first question they ask us is there correlation? There is. Okay, they're both increasing. There's a relationship here. Causation. Do I think that working more hours is making me earn more money? Absolutely. Okay. And then the last thing we got to do here is we got to provide an explanation. So explanation. There is positive correlation because they're both increasing. There is positive correlation because increasing the amount of hours worked that's a U is causing, keyword here causing, right? Because we have to explain whether or not there's correlation and there's causation. Is causing the amount of money you make to increase as well. Okay, so it's very similar to the ones we did before, just they wanted more of a written explanation than just a verbal one.